Hello, everybody, and welcome to our session today at the Analytics Forum. Uh, this session is on mastering time series analytics with Spotfire. My name is Ahmad Katahi. I'm a director of data science.
Hello, my name is Adam Faskowitz, and I am a lead data scientist.
And this is the boilerplate disclaimer that everything we talk about here are ideas about time series and how we like to enable you. The product timelines and features, they will come to you at or through the official channels. Without further ado, let's talk about the topic of the day, the time series and why we care about it in Spotfire. So, when we think about time series data, especially for some of us who may be a little bit less experienced in the real world problems than the manufacturing and energy world, it might sound like, what's so special about it? It's always good and clean and perfect, right? But is it really the case? So you may have seen, if you have been around even a little bit, you may have realized that sometimes data comes in as a little bit, off different scales. It needs normalization. They can be, one signal versus another signal from different systems can simply be on two different units, as simple as that, not to mention all sorts of other things that can happen. In some other cases, you may be dealing with a lot of samples. People may get a little bit too enthusiastic or greedy about taking samples, and the result, as you see on the top right, will be a time series signal that is extremely dense, so you don't even know where to pay attention to. All the details are obscured. In some other cases, you may have time series signals that are actually focusing with more resolution in places that is actually not necessary, and vice versa. So the result is some really sparse areas in your signal that neglects a lot of the details and resolution that you need to have before you can even start doing your downstream analytics. In some other cases, this is a beautiful flower, perfect, but then something is sitting on it. So I don't know if you have noticed it, so there might be some noise sitting on your data, basically turning the otherwise beautiful signal into something that doesn't look that perfect and beautiful anymore. So in this case, on the time series on the top right, you have a kind of a sine wave shape, but clearly there's something sitting on top of it that you need to get rid of. In some other cases, you have irregular samples. You see towards the beginning of the time series, you have a little bit of a larger distance between your samples, and it gets denser as you move forward toward the right, and you need to take care of that. And this is obvious. It's a little bit wrinkly or wrinkled up, so it needs to be smoothened. The example is, you see a lot of jitters, and before you can look at any sort of trend or seasonality or behavior that our human eyes and brain can understand, or your downstream analytics can capture, you need to smoothen the signal. So now that we looked at some of these motivating examples, and we could have gone for 5 times more examples, let's take it back a little bit and talk about why time series even matter. On the one hand, it's important because it shows the dynamics of the system, the whole time dimension. Even if you have multiple signals in a multivariate environment, the time dimension is special because it brings a notion of sequencing and dynamics to your system. And to be fair, actually, sometimes when we say time series, it's basically sequential data for example, oil and gas operations. The sequencing index could be depth or distance, right, as opposed to time. We just call them, colloquially, all of them time series. So same principles apply, or same reasons. Also, on the other hand, this type of data shows up across various industries, including financial systems and insurance and manufacturing, high-tech manufacturing, energy, you name it. So those are the goods, but then there are challenges. On the bottom, you see, the data, as we saw several examples of, could be notoriously dirty because of all sorts of technological challenges. Many of these industries are pretty established, old. When they existed or came into existence, data was a second thought, so they were not even built for capturing data, resulting in all sorts of challenges. And also because of this, unique nature of time or distance or depth across the multivariate environment, it typically requires a special type of analytics to capture the sequence or preserve it, and sometimes you have to pay attention to specific windows, and you pay attention to specific frames in your time series, and forget some other parts to keep things feasible and not run out of memory or compute power. Our vision to basically go about this whole value opportunity on one side and challenges on the other in Spotfire is to enable a whole host of these operations that we talked about within Spotfire for our users. So they don't have to leave the product or write many lines of code outside the product. And to do that, to get to that vision, we have devised a modular and extensive approach to developing a number of these functions. So they can, the user, you can plug them in and you can use them as Lego pieces, whatever fits your analytics. And we have designed them as compatible as possible, exactly like Lego pieces. So you can basically mix and match and choose whatever fits your purpose, and build higher level applications that fit your business requirements without having to write a lot of code. And so what we have been developing specifically, to get into the specifics before I pass it over to Adam to show us a demo, are to begin with, a lot of these signals require some pre-processing. Some examples of which I briefly mentioned in my opening examples, but Adam will walk us through a bunch more. And right after that, or throughout the process, you may need to smoothen them. Some other ones that we may see a little bit less of today, but toward the end of this presentation, I encourage you to look at some of our resources and references for the rest of these items. We enable, we publish functions and DXPs and other resources to decompose time series into trends and seasonality and noise, or even if you want to filter it based on frequency components as a Fourier analysis. A huge area is anomaly detection of interest to pretty much any industry. You pick. Picking anomalies in a multivariate complex environment is both of huge value and extremely difficult, especially if you don't have ground truth. And the last one is slightly different. It's more of a technology as opposed to a mathematical algorithm, given the importance of the pi system across various industries. We have developed a bunch of connectors and DXPs, so that you can leverage them to access your pi data very easily. So with that, without further ado, I pass it over to Adam to walk us through a few interesting demos.
Great, thank you, Ahmad. So today, what I'm going to be showing you is our time series toolkit here in Spotfire. So the data that we're looking at in this DXP is San Francisco weather data, and then in particular, precipitation data, so rain data, over the past 100 years. So on the top right, what we're looking at is all of the daily values of precipitation over time. But essentially what I'm trying to do here in the end is create a decent forecast of how rainy it's going to be in the beginning of this year. Now, the problem is that time series can be very hard to deal with if they're not pre-processed, smoothed, decomposed correctly. So what we've built is a series of different functions, Python functions, that'll be able to pre-process our time series, which I'll show some examples of how we're using. So if I click onto this different tab, I could show you each of our 4 functions and what they do. So on the top is our original time series, and we see that there's a ton of gaps in it, and there's a bunch of like daily fluctuation that make it kind of hard to make out. So we'll use these 4 functions to help us. So the top left, what we have is imputing missing values for our time series. So this is where those gaps are in the time series. We want to fill those in with 0 because there wasn't any rain on that day. Then there's normalizing time series. So this is taking the range of the Y values and putting them into a new range with a new minimum and maximum. So it could be stretching, shifting, things like that. And then there's the same concept as normalization, but done on the x-axis. So this is done on time. So this is where I could say I have this new minimum for a date and a new maximum and coerce my data into that. And why this could be like valuable as an example is that, so we have San Francisco weather data in this case, but we might also have Australian weather data and we want to sync them up. So what we do is we'd offset it by 6 months so that the seasons align correctly. And then on the bottom right, what we have is resampling time series. So essentially what this is doing is it's changing the frequency of our time series. So right now we're looking at daily data, but we could go in both directions. We could request that we would have hourly data, or maybe every 6 hours, 12, something like that. Or we could make it where give me aggregations over every week, every couple weeks, things like that. So going back to the first page, what we've built is a way for us to be able to execute the functions that we created. So on the left, we have the 4 different options, each as their own dropdown. And if I click onto this missing value imputation, what we see is the time series table, which has date and precipitation. So I have those selected. I've selected my index as the date, and we can set up all the rest of these parameters accordingly. So exposed here, we can, in different ways, impute based on whether this is numeric or non-numeric data. So in this case, though, this time series, the missing values have a meaning, and it's very easily well defined. Sometimes it could be very hard to make out, and you need to use some of these other methods. So like taking the previous valid value, linearly interpolating the data, things like that. But in this case, it's safe to just impute it with a constant and have that constant as 0. So after doing that, I feel good about my missing value imputation. I can move on to the next function that I'd like to use, and that's resampling. So right now, like this, because this is daily data, we see that all these fluctuations kind of really make it hard to make out the trend. So what I'm going to do is I'm going to aggregate this data over a 2-week period. So I'd rather have that. So for this resampling rule, I could simply put 2W, and that'll say, give me the data every 2 weeks. But I could put this in for D, and it could give me a day. I could put 12H, that can give me 12 hours. So, whatever works best for the data. In addition, we can also decide to do this based on the number of samples. So let's say I have like 1,000 points in my data set. I could say that, give me 300 samples, and it'll coerce that data into evenly spaced intervals. That's an important thing about this resampling function. So that can be very good because the output of it will always be evenly spaced data points, which is really important as it can be a challenge to deal with the time series data if not. And so in this case, though, I have the 2-week interval, and I will fill up this with the aggregation of taking just the mean in each of these sections. But we could see we could do different types of functions for filling that data. So that's the resampling. And now the next one is min-max normalization. This one's pretty simple. I have the range of Y values for this precipitation. I just want to put it between 0 and 1, just so it's easier for me to understand. Then the final thing is index normalization. I'm not going to use it here because it doesn't particularly make sense, but we could show that using the dropdown, we have access to those configurations too. Now on the top, I'm going to set up basically my pipeline. It's going to run each of these functions in order that I've placed. So I've had 1, 2, and 3, and then I could just click this run pre-processing pipeline. And after doing that, that creates this pink result on the bottom. So we're looking at the same data in this light blue where we have all these fluctuations, but now we've kind of cleaned up the data. We see that like their points are filled in at 0, and we seem to have a little less, extreme fluctuations on a day-to-day basis. But so because this time series doesn't particularly look perfect yet, what we would like to do now is maybe smooth the data. So moving on to our next page, we have a very similar setup where we can look at some of the smoothing functions that we've created. So in a similar way, we could set up the data that is going to be set into these smoothers. And then I have a numerous amount of smoothers to choose from. So I have some basic smoothers as well as some advanced smoothers. Each of these have their own parameters that I could also select. So right now I had like 3 different smoothers, but if I click, I want to add in the moving average, I can click that and click run smoothers again. And what this page is meant to be is like a very iterative and exploratory page. So what I just did is I had, we see this new smooth curve that's orange here, and this is the moving average. Now, like just by looking at it, we see that it kind of looks a little bit off. So what I could do here is I could go back into the configurations. Maybe the window size shouldn't be that big. It should maybe be something like 10. So I can adjust that, and then I can rerun the data. Now we see that it seems like it looks like the smoother outputted a little bit better, but maybe still not the best amongst my smoothers. But it's all really going to depend on the data that you bring in. Different smoothers can work well under different circumstances. So it's best to try out all the functions, see what works best. So I think in this case, the lowest smoother is the one that I feel most confident about. So I'll use that to try to create my trend. So right now, what we're seeing is on top is the original data. We have all of these gaps, a lot of fluctuations, very clumpy. And what we're going to try to do is open up the properties of the visualization in Spotfire. We could try to add a line in this lines and curves in the properties. We could try to add a forecast. So forecast using Holt Winters, you can do this by clicking on this add and then forecast Holt Winters. But we've done that and we see that there's nothing there. And what we see on top in this little blue icon is saying that, well, there's multiple empty values in succession. It can't figure out how to create this forecast. So thankfully, though, what we're able to do through our kind of sequence of steps here is create this nice smooth curve in the end for which we can actually create a forecast for. So doing that same exact thing, we're able to get an actual forecast here on the bottom, along with the confidence bands of that forecast. And I think the prediction, definitely got the trend right. But as someone who lives in San Francisco, I could say that the beginning of this year was actually extremely rainy. So it definitely even became an anomaly where it was probably even surpassing the upper confidence interval here. So the next and final function that I'll show you how to use is decomposing our time series. And I'll show how we can actually access this through our data function flyout. So this flyout here, this icon on the left, if I click on it, it could show me all of the data functions that I have pinned basically as like my favorites. And if I click on this time series decomposition, a new window appears that makes it very easy for me to configure and set this up. So all I need to do here is like just give it my time series. So I'll find the clean time series that I'd like to work with. I'll select on the date in the precipitation column, get rid of snow. And just after doing that, I could click this OK button. And now it's been set up. It's actually run. The data function is now complete. And it's asking, what do you want me to do with the output? So for this, I'll have it output to a decomposed time series table, which I set here. And now I could click OK. And now this is showing me that the table is successfully created. So now I could move on to our final page where we could explore these results. So our time series, it could be broken down into 3 different components. So there's the trend, which is kind of like the overall trend of how rainy or not rainy any kind of given period of time was in our data set. Then there's the seasonal aspect, and this is taken into account, well, in the winter months, it's going to be most rainy. In the summer months, it's going to be least rainy. So it's a combination of trend and a seasonal curve that's going to get you basically what we would expect the amount of rain to be at a certain time is. But that's not always going to be perfect, because then there's going to be a residual. So residual is the difference between that calculation and what the actual amount of rain was. Now, what's particularly neat about this page is that it could be a really cool exploratory tool to just like find anomalies in the data. So here on the left, we have a Spotfire mod. This is a bubble chart that we've added here into Spotfire. And if I click on kind of this biggest residual here, what this is showing is that looks like in right around Christmas in 2002, it was like around an average kind of rainy time of the whole data set. So not particularly rainy or not rainy for this like year. But the seasonal aspect was this is typically your most rainy point of the year, but the residual is still super high. And what this is essentially indicating is that this was a very rainy period of 2 weeks, like much, much more than anything else that we're even seeing here. And then what I also found kind of funny is that if I click on like this small dot right here, this is where the residual is smallest in the data set. And this is actually only from like a month earlier. So this is like 4 weeks earlier. It's in November of 2002. And when combining the, it's around the same prediction of how rainy it's going to be, except for the residual is now negative 1.5, basically indicating that there was no rain during this period. So like within the span of a month, we went from a time where we expected it to be pretty rainy and it wasn't raining at all, compared to we expect it to be very rainy and it, blew off the gears and ended up being the rainiest season in decades. So very cool tool that we're using here with decomposing our time series. I hope you found this insightful, and now I'll turn it back over to Ahmad to help wrap things up.
All right, thank you, Adam. That was great. We saw a bunch of these functions in action in Spotfire, and actually, let me start by saying that the last piece you showed was figuratively and literally like cherry on the top. That showcased the visual prowess of Spotfire in visual analytics. What we saw in this presentation was we started by seeing why time series matters to various industries and why it is challenging. And from there, we quickly pivoted into these specific areas: time series pre-processing, smoothers, decompositioning of time series that Adam showed us. And let's not forget these other functions that are available actually in some very rich formats. Anomaly detection has its own presentation in this conference, and we continue to add functions to this repertoire of functions. And the big takeaway for everybody is that not only time series is important, but also what we have created and continue to create enables various personas, from the more technical developer type hands-on people by these publishing these Python functions and data functions, all the way to a higher level like DXPs and visuals that we publish to the community in various channels. And in terms of our future developments, we are looking at different phases of development. Pattern recognition, leveraging matrix profiling algorithm that famously came out of University of Irvine a few years ago, and that will enable you to pick out and choose a pattern of interest in your time series, and then apply that efficiently throughout your whole time series, and pick out similar patterns. And you cannot talk about time series without talking about forecasting. That's also an active area of development, which will add to the existing features when it comes to forecasting in Spotfire. And to close out, please don't forget to check all of these resources. Mainly in our community AI on demand page is this collection of vertical applications from various industries that we have collected over the past few years for you. They tend to be deeper applications for a number of industries. Spotfire Demo Gallery is this huge collection of several tens of these clickable interactive demos in Spotfire that you can interact with. I highly encourage that to check them out. Dr. Spotfire is this famous series of enabling videos that we have been publishing over the past few years. There's something of value for pretty much anybody who uses or is interested in Spotfire. And last but not least, the exchange is this collection of data functions and lower level components that we publish for time series and other types of analyses. And without further ado, I'd like to thank all of you for joining us for this session, and enjoy the rest of the conference.